So let me show you how to solve some of the problems that we're working on for the lab. So here's a problem, the first problem that we are assigned, and this can be solved a couple of different ways. If we just go and put this into the matrix and solve it using the ODE, then it can solve it, but you get a peculiar result. So you get two results. Let's take a look at one of them here. So this says that L equals this stuff. Well, it has this I in there. I is the square root of -1. It's an imaginary number. And we also see that there is a negative sign underneath this square root sign. So it's a peculiar form, and I must say I'm not quite sure why it does it this way. But if you recognize that this is the square root of -1, and the square root of -1 times this thing, the square root of -2 dt, is equal to this. So the square root of -1 times this is equal to that. And then the square root of 2 times the square root of this stuff equals that. And that's the result. So Scientific Notebook in fact gives you the right result, but it's in kind of a peculiar form, and you need to know how to work through this form in order to take advantage of this result. So in some ways this is unfortunate, because if you're just starting out, as many of you guys are, then you probably get this result and it's not really too meaningful. It looks just fairly cryptic and you can't really deal with it. And so what I think we need to be able to do then is have the method of separation of variables to fall back on. And so let me show you how to solve this using separation of variables. So there's the equation, and we can separate it. The dependent variable is L, and the independent variable is T. So we have to get the variable L over on one side and the variable T over on the other side. So we do it like that. 2 and D, those are constants, so they can be on either side. And we'll just copy this and we'll get rid of those fractions. So this is now the separated form, and we can integrate this both sides. Actually, let me keep that separated form, copy and paste again, and then integrate both sides. So this is just a constant. We integrate dt, and we're going to integrate LDL. So that is best done, I think, if we split it up into two steps. First we'll do the left side, and that equals the L squared divided by 2, and this will equal just 2 dt. So we can take these results and substitute back in there, and it amounts to that one equals 2 dt. And we need to include the constant of integration. Okay, so the procedure now is to use the initial condition that L is equal to 0 at time equals 0. And we'll use that to solve for the constant. So the procedure that we used in the previous video was to put it in square brackets and substitute in the condition that L equals 0 there at t equals 0. And we make that into a subscript, and we use evaluate to do the substitution, and it just gives us that C1 equals 0. Okay, so we need to do that each time. We need to solve for the constant each time. In this case, it just gives us a result that equals 0, so we can get rid of it like that. And now we can solve for L. And so I'm going to get this step is setting C1 equal to 0, and then this step will be solving for L. And so then if I take the square root of both sides, I get L equals that stuff, and square root of 4 is 2, so there's the final result. Okay, now if you're going and doing this, you should put in some text describing what each step is doing. I'm leaving that out just for brevity, but you should do that so that everybody can follow along. And what I'm going to do now is try the check. So to check this, we take the result here and substitute it back into these equations. So there's the equation, there's the result. So the first thing, let's do the initial condition. Well, this is pretty straightforward. I'm not sure. Oops. Let's get rid of that. Okay, well, Scientific Notebook only goes back one step. So let me just go and get the result here real quick. So that's the result. And let me copy this down here. We see that when time equals 0, L equals 0. So this so it satisfies the initial condition. And to see if it satisfies this equation, we substitute it in. The first thing we do is take the derivative of both sides. So, or the derivative of dl dt. So that's going to be d dt of that stuff. And that's going to equal that. And this side of the equation is this. So this is going to equal let's see. Okay, well, let's leave that alone, and we'll deal with the right-hand side of the equation. So L is equal to this stuff. So we'll go and we'll do the substitution, and let me go and do it this way. So we got that, and then L is equal to this. So that's going to equal 2's just cancel, obviously. And we get the same form. So this is the left-hand side, and this is the right-hand side. They're equal. And so we verify that this result here satisfies that equation. What we also recognize is that this is a little bit of a cumbersome form like that. The way we would normally do this, I think, is to write this as if you have d divided by square root of d, that equals square root of d. So if we simplify this down, it's going to be this: d over t t square root. And that's the same for this side as well.